Hello, viewers. In this tutorial, we'll be looking at operations on infinite sets. But here we are going to restrict ourselves to intervals. So, how do we perform union? How do we perform intersections when we are dealing with intervals? In our previous video, we've seen how to do this when we have a set that is finite, sets that are finite. So, we'll just consider two examples. Example one, we have set A and we also have set B. Set A is an infinite set, as we can see. It's from minus infinity to minus 1, union 2 to infinity. And set B is an open half open interval, minus 2 to 3. The goal is to find what is A intersection B. So let's start with A. To answer this type of question, we use the number line. So let's try to represent A on the number line. If this is 0, so we have minus 1 here, and then somewhere here we're going to have 2. But look at A. A is from minus infinity to minus 1. So we can draw our arrow. When we get to minus 1, we put an open interval because it is open at minus 1. Then we have closed at 2. So from 2, we can you put a shaded circle, then we continue. But remember, this is going from infinity to minus infinity. So actually, this is A. This is what A is. Then what is B? Let's see B. B, it's simply B here. We try to put B also on the same number line. B is going to start from minus 2 to 3. So if this is minus 1, minus 2 is going to be somewhere here. And if this is 2, 3 will be somewhere here. So we can say we put an open circle here because you can see it is open at 2. But at 3, it is closed. So we put a closed circle and we try to connect these two circles. All right. Now we are looking for intersection. Remember, what is A intersection B? We discussed this before. It's every element such that what x is in both A and what and x is in what is in B. In other words, we take what is common. So we're going to look the area that is common, where there is an intersection. So let me remove this one. So if you look, you have this one here, the red and the black region. So this is also a common region. So we have two regions that is common to the red and the black pen. So this will give us our intersection. Now, what is it? This area is going to be what? 0, you can see here, minus 2 is open. So our A intersection B is just going to be from minus 2 to here, minus 1, which is also open. Then we have two parts, so you have to unite them using union. That's the connection. Then you take the second part. The second part here, you have 2. So this is 2. You see this 2 is circled, it's closed. Here also you see it's a thick line, so it means it's closed. So we're going to use a closed interval 2. And also here you can see this is also closed and this is also closed. So this is going to be 3. And so this is the answer for this question. So the right option is C. All right. So just to explain something here, you see here, this is closed. Let's assume this is open. Assuming here it's open. Then the intersection between open and closed, you will take the open circle. But since both here is closed and here also is a thick line, meaning it's closed, then you have to take it to be closed. So let's go for another example. Example number 2. For example number 2, we have A. So this is A. Let's try to write A in terms of interval. Let's just try to write it very well here. It said X means X is less than equals to minus 3, and union X such that X is greater than 1. So what this is saying, this is simple A. In other words, A is just from minus infinity up to minus 3 close, right? Union this X greater than 1 is just the interval 1 to, need to use a different pen. So let's say A, it's minus infinity to minus 3, union 1 to what? 1 to infinity. This is A. And what is B? If we look at B, so B, we can have it here. B is just what? B is also a union of two sets. So B is from 0 to where? 0 to 3, but both are closed now. 0, 3, intersection 1 to 4, 1 to 4, but both open. So this is B, right? So what is the goal? We want to find A intersection B. So this B, let's try to write B. Maybe we can write it in a more simpler way since it's an intersection. If you look at this B, we can write it like this. Let's use our interval. If this is 0 and 3, so let's say we have 3 somewhere here. So 0 to 3, both close. So it's going to be 0 to 3. And we have what? We have 1 to 4. 1 to 4 means if this is 0, this is like 1. So 1 to 4, and here is going to be 4. So it's open, right? So you see where it's common, the intersection is just this part. So in other words, actually B, it's simply what? It's simply going to be just 1 open to where? To 3 close. So this is actually what B is. But here you can see it's written as the intersection of two sets. So this is B. And this, the whole of this still remains our what? Our A. So now we need to find the intersection between what? Between these two sets. So let's put them on a number line. Let's write A. Let's see what does A look like. A is, let's say this is 0, this is 1. So A is going from 1 to infinity. So this is going here. And what's from minus infinity to minus 3. So let's say this is minus 3. And this, let's say this keep going, right? So minus infinity to minus 3. But this is going to be close, right? So everything here we have is just A on red, right? Okay. So now let's draw now B. I'm going to use black for B. So this is B, right? This is B, which is 1, 3. Okay. So let's have the B here. 1, 3 means this is 1. 3 is going to be somewhere here. So this is 3. And you can see it is open at 1 and closed at 3. So you see, where do we have the intersection? So the red one is now, this is part of A, this is part of A, but this is what? This is our B, the black line. So you can see where will be the intersection. Intersection will be where they meet, which is just this portion here. And so it means that A intersection B is nothing but what? This is just going to be open, right? This is going to be open. And what else? This is 1 here, and here is what is 3 close. So we have 1 open to where? To 3 close. That is the intersection, A intersection B as well. So you can see that A intersection B is actually the same thing as our what? As our B.